So number 10, for the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of negative 4? Well, we can just use these inputs here and plug into this original equation. So if g of x equals ax squared plus 24, and we know g of 4, so 4 in this case is x, and 8 is y, so we can just plug that in. So 8 equals a times x squared, which is a times 4 squared plus 24. So we have 8 equals a times 4 squared. 4 squared is 16, so 16 times a plus 24. And we want to isolate a, so we can subtract 24 from both sides. So we have negative 16, because that's 8 minus 24. So negative 16 equals 16a. Divide both sides by 16. A equals negative 1. And now we know that, I'll write this here, g of x equals negative 1 times x squared plus 24, which is just negative x squared plus 24. We don't have to write that negative 1. And well, now we can just plug in negative 4 for x, because we're trying to find g of negative 4. So g of negative 4 equals negative times quantity negative 4 squared plus 24. Okay, so let's see. Negative 4 squared is negative 4 times negative 4, which is just 16. And we slap on the negative at the beginning, and then add this 24 at the end. So negative 16 plus 24, well, that's the same thing as writing 24 minus 16, which is just 8. So 8 is our correct answer. Number 11. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. And the question says, what was the price per pound of beef when it was equal to the price per pound of chicken? Well, that makes the question pretty straightforward. If we're trying to find the price when it was the price of beef when it was equal to the price of chicken, we can just set these two equations to each other, equal to each other. So we can have 2.35 plus 0.25x equals 1.75 plus 0.4x. And then we can just solve for x and plug into this top equation to find the price per pound of beef. Okay, so first of all, let's subtract 0.25x from both sides. And then that leaves us with 2.35 on the left side equals 1.75, and 0.4x minus 0.25x. Well, that's basically the same as writing 40x minus 25x, and then just dividing by the scale factor. So that's plus 0.15x. And then we can subtract 1.75 from the right side to get 0.6 equals 0.15x. Divide both sides by 0.15. X equals, so let's see, 0.6 divided by 0.15. That's basically 16 or 60 divided by 15, which is 4. And if we plug in x equals 4 to this top equation to find the price of beef, we have 2.35 plus 0.25 times 4. 0.25 times 4, that's just 1. And 2.35 plus 1 is 3.35, which is D. Okay, number 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? Well, if the line passes through the origin, we know it passes through the point 0, 0, because that's the coordinate pair that represents the origin. And if we plug this into our y equals mx plus b form, we can pretty much cancel off this plus b part because it's plus 0. So our line has the equation y equals mx. And what does m mean? Well, m is just a slope. And what is the slope in our question? It's 1/7. So if we plug in 1/7 for m, we have that our line has the equation y equals 1/7 x. And then we can just pretty much see if any of these answer choices fit this relationship between x and y. I'm going to start by trying to plug in answer choice C, because that's an SAT tip right there. Whenever you're guessing and checking, always plug in answer choice C first. Scientifically proven to be the most common. So let's try it. If 7 is y and 7 is x, we have 7 equals 1/7 times 7. Here, I'm going to write it out. 7 equals 1/7 times 7. And 1/7 times 7 is 1. 7 does not equal 1, so it's not C. And then after you try C, you just try the answer choices around it. So let's try D. So we have 2 equals 1/7 times 14. And 1/7 times 14 is 14 over 7, which is 2. So 2 equals 2. That's correct. Answer choice D is correct. Okay, number 13. If x is greater than 3, which of the following is equivalent to this mess here? I'll write it out on the side. To make this into a more digestible form, we can just multiply by x plus 2 times x plus 3 over x plus 2 times x plus 3. If you see, this gets rid of this ugly denominator here, and it's legal mathematically, because if you cancel all this out, it's just 1. So you're basically just multiplying this entire expression by another way of rewriting 1, so we can do that. And if we apply this, multiply this expression by 1 on the numerator, so our numerator is x plus 2 times x plus 3, and our denominator, well, this just replaces the 1 on the top, so we have x plus 2 times x plus 3, or excuse me, plus x plus 3. And, well, personally, I don't want to FOIL this out immediately. I'm kind of lazy, so I'm just going to leave it like that. But this denominator is easier to work with. X plus 2 plus x plus 3, that's pretty easy to compute. Just combine like terms, right? X plus x is 2x, 2 plus 3 is 5. So we're looking for 2x plus 5 in the denominator of our answer choice. Already cut out these because they don't have a denominator. Look at that, answer choice B is correct. Number 14. If 3x minus y equals 12, what is the value of 8x over 2y? Okay, well, right off the bat, anytime we're dealing with exponents, you want their bases to be the same. And this is actually pretty easy to manipulate in this question, because 8, that's just 2 cubed. So we have 2 to the third power to the x power over 2 to the y power. And if you know anything about exponents, you know we can rewrite this as 2 to the 3x over 2 to the y. And another important thing about exponents is that if you divide them and they have the same base, you can temporarily forget about their bases and just subtract their exponents. So this is just equal to 2 to the 3x minus y. And, well, we know what 3x minus y is equal to. It's given in the question. So this is just equal to 2 to the 12th. A is correct. Number 15. If quantity ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b equals 8, what are the two possible values for c? Well, right off the bat, we have two quadratic expressions, one unfactored on the right side and one factored on the left side, and we're trying to equate them. Okay, well, if we're trying to do that, we want them to be in the same form, right? So I'm just going to multiply, I'm just going to multiply this left side out. Just expand. So ax times bx is a bx squared plus 7ax plus 2bx plus 14. And that still equals 15x squared plus cx plus 14. So straight away, we can see that we're probably going in the right direction because we have a plus 14 here, we have an x squared term here, we have something in the middle that we don't have to worry too much about now, but yeah. So let's ignore the 14 for now because we know it's common, it would cancel out if we did anything with it. So we have abx squared plus 7ax plus 2bx equals 15x squared plus cx. And yeah, so 15, that's the product of a couple numbers, right? A and B, and that's what ultimately we're trying to find. Two numbers that multiply to 15, and if we multiply 7 by it and 2 by the other one, they add up to some value of C. And what are the possibilities for that? So the factors of 15 are 15, 1, 5, and 3. But what do we know about A and B? They add up to 8, right? And do 15 and 1 add up to 8? No, they don't. They add up to 16. But 5 and 3 add up to 8. So we know 5 is A and B is 3. So we have 5 times 3x squared, basically 15, plus 7 times 5x plus 2 times 3x equals 15x squared plus cx. Multiplying this out, we have 15x squared plus 7 times 5 is 35x, and 2 times 3 is 6x. And if we ignore this 15x squared term here, because we have it common on both sides, we have 35x plus 6x, which is 41x, equals cx. So c equals 41. And the question asks us to find two possible values per c, but none of the answer choices, except for D, have 41 in it, so that's our correct answer. Okay, finally moving on to the non-multiple choice questions. Number 16. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? Well, that's pretty simple. That's just a difference of squares. Then t squared minus 4 equals t plus 2 times t minus 2. So our solutions are negative 2 and 2, but t is greater than 0, so the value of t is 2. Number 17. A summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch are determined to be 1800 feet, 1400 feet, 700 feet, and 800 feet respectively. So AB is 1800, EB is 1400, BD is 700, and CD is 800. Segments AC, and DE intersect at B, and angle AEB, so AEB, and CDB have the same measure. Yeah, it's pretty clear because of vertical angles. And what is the value of x? X is this length AE right here. Okay, well, it's clearly a proportion, right? So this right here is half of this length, so that means BC is half of this length, and DC is half of AE. So we can set up the proportion that 700 over 1400 equals 800 over x. We could cross multiply, but that would take a while, so we can just see this simplifies to 1/2. So 1/2 equals 800 over x. This is a lot easier to cross multiply. 1 times x equals 2 times 800. That means x equals 1600. 18. X plus y equals -9 x plus 2y equals negative 25. According to the systems of equations above, what is the value of x? Well, that's pretty easy. That's just very similar to the systems of equations questions we dealt with earlier in the exam, but this time we don't have choices. So let's do the same thing we did there and just rewrite out what we have. Cancel the x using elimination. So we have x plus y equals negative 9 and negative x minus 2y equals 25. Cancel the x here, add these two. We have, so y plus negative 2y is just negative y. So negative y equals negative 9 plus 25. That's the same thing as 25 minus 9, that's just 16. Divide both sides by negative 1. Y equals negative 16. But that's not what we're asked for. It's x, right? So we can just plug this in to either one of these equations to solve for x. The top one looks a lot more simple to me, so I'll just do that one. So x plus negative 16 equals negative 9. That's the same thing as writing x minus 16 equals negative 9. And we want x, so we can just add 16 to both sides to isolate. So we have x equals 16 minus 9, x equals 7. Number 19. In a right triangle, one angle measures x degrees, where sine of x degrees equals 4/5. What is the cosine of 90 degrees minus x degrees? So this 4/5 right here, that immediately triggers right triangle in my head with side lengths 3, 4, 5. So 5, 4, 3. And we know sine of x, so ka, toa. Sine of x is opposite over hypotenuse. So we can set this as angle x. And then sine is just 4 over 5, opposite over hypotenuse. So this right triangle accurately represents our question, our situation. And we want to know what the cosine of 90 minus x is. Well, we can apply a little trick here. This is a cofunction identity. And what it says is that cosine of 90 minus x degrees equals sine of x degrees. And we already know sine of x degrees is 4/5. So our answer is just 4/5. Final question. If a equals 5√2 and 2a equals root 2x, what is the value of x? Okay, so we know a equals 5√2 and 2a equals 2 times this, right? So a equals this, and that means 2a would equal 2 times 5√2. And it's also equal to root 2x. So we have 2 times 5√2 equals root 2x. And yeah, we can just simplify from here. 2 times 5√2 is 10√2, and then root 2x is, we can just leave it as root 2x. And okay, to solve for x in this situation, we'd need to get everything under the radical on both sides, right? So how can we do that? Well, you can recognize 10. What does 10 equal? 10 equals the square root of 100. So we can rewrite this left-hand side as square root of 100 times square root of 2, or square root of 200. This right side stays the same. Square root of 200 equals the square root of 2x. We can cancel the square roots. So we have 200 equals 2x. Divide by 2 on both sides. X equals 100. And you're done with the exam. Thanks for watching.